Section 5.4.3 Application of sum and difference formulas. This video is about writing sum of a sine b theta and b cosine b theta as square root of a square plus b square sine b theta plus c and square root of a square plus b square cosine b theta minus c. Write a sine b theta plus b cosine b theta as square root of a square plus b square sine of b theta plus c, where c equals to arctangent b over a and a is bigger than 0. So let's start with a sine b theta plus b cosine b theta, and let a is equal to k times cosine c and b is equal to k times sine c, such that if we square a and plus square b, then it should be k cosine c square plus k sine c square. So if you expand the square, it becomes k square cosine square c plus k square sine square c. We can factor k square, it gives you cosine square plus sine square. Now cosine square plus sine square is 1, so it becomes k square times 1 or equals to k square. So we have a square plus b square equal to k square, or we can rewrite as k square equals to a square plus b square. Now we take the square root, we can get k equals to the square root of a square plus b square. Moreover, if we divide b by a, we have a k sine c over k cosine c. K cancels, you have a sine c over cosine c. Sine of c over cosine c is a tangent c. So we have a b over a is a tangent c. Then by the inverse definition of inverse function, we can write c equals to arctangent b over a. So let's start with a sine b theta plus cosine b theta. So now we substitute a equal to cosine of c and b is equal to k sine of c. So this becomes k times cosine of c sine b theta plus k sine of c times cosine b theta. Now we can factor k and we're left with cosine c sine b theta plus sine of c cosine b theta. And now we rewrite, and we can write as k times sine b theta times cosine c and cosine b theta times sine of c. And it looks like this formula: sine u cosine v plus cosine u sine v, which is sine of u plus v. So with u is equal to b theta and v is equal to c, so this condenses to k equal to sine of u plus v, which is b theta plus c. And now we can replace the k, which we found square root of a squared plus b squared. So we have equal to square root of a squared plus b squared sine b theta plus c. So now we're going to write a sine b theta plus b cosine b theta as square root of a squared plus b squared cosine b theta minus c, where c equals to arctangent a over b and b is greater than 0. So let's be a sine b theta plus b cosine b theta, let a equal to k sine c and b is equal to k cosine c. So if I square a square and b square and add, so we have is equal to square of k sine c plus the square of k cosine c. Now this becomes a square plus b square equals to, so when you square, it becomes k square sine square c plus k square cosine square c. So now we can factor k square and we get sine square c plus cosine square c. We know sine square c plus cosine square c is 1. So this becomes k square times 1, which is k square. Now we can rewrite this k square equal to a square plus b square. And if we take the square root, we can get k equals to the square root of a square plus b square. Moreover, if I divide a by b, then this will be equal to k sine c over k cosine c. Now k cancel, it is sine c over cosine c. And we know sine of c over cosine of c is tangent c. So we have a over b equal to tangent c. So from here, using inverse definition of tangent, it becomes c equals to arc tangent a over b. So let's rewrite this as sine b theta plus b cosine b theta and substitute a equal to k sine c and b is equal to k cosine c. So we get k sine c sine b theta plus k cosine c cosine b theta. Now we can factor k and we get k parenthesis sine c sine b theta plus cosine c cosine b theta. And now we can factor k. We already factored. So let's rewrite. So we switch this one. So we write sine b theta sine c and cosine b theta cosine c. Now this is similar to this formula sine u sine v plus cosine u cosine v, which is equal to cosine u minus v. With u is equal to b theta and v is equal to what? C. So we can, so we get this is equal to k times cosine of b theta minus c. Now we can replace k equal to square root of a square plus b square. So we get square root of a square plus b square times b cosine theta minus c, where c is equal to arctangent a over b and b greater than 0. So here is an example 1. We're going to write 5 sine theta plus 12 cosine theta in the form of square root of a square plus b square sine of b theta plus c, where c equal to arctangent b over m. So let's start with f5 sine theta plus 12 cosine theta. Let a is equal to 5, b is equal to 12, and b is 1. So first we find c. C is the arctangent b over a, which is arctangent 12 over 5. Using calculator in radian mode, you get 1.1760, rounded to 4 decimal places. Now we substitute a is equal to 5, b is equal to 12, b is 1, and c equal to 1.1760 in this one. Square root of a square plus b square is sine b theta plus c. To get square root of 5 square plus 12 square times sine of 1 theta plus 1.1760. So we simplify it, so it becomes 25 plus 144 square root, and this becomes sine theta plus 1.1760. This becomes square root of 169, and which is 13, so we have 13 times sine of theta plus 1.1760. So here is an example 2. We're going to write 5 sine theta plus 12 cosine theta in the form square root of a square plus b square cosine b theta minus c, where c is equal to arctangent a over b. So let's start with the 5 sine theta plus 12 cosine theta. Let a is equal to 5, b is equal to 12, and uppercase b is 1. Now c is equal to arctangent a over b is equal to arctangent 5 over 12. So, which is 0.3948 using calculator in radian mode. Now you're going to substitute a is 5, b is 12, uppercase b is 1, and angle c is 0.3948 in this formula. Square root of a square plus b square cosine b theta minus c. And this becomes square root of 5 square plus 12 square cosine of 1 theta minus angle c 0.3948. Now we simplify. So 5 square is 25, 12 square is 144, and this 1 theta will be theta. So cosine theta minus 0.3948. 25, 140 make 169, square root of 169, which is 13. So the final answer is 13 times cosine theta minus 0.3948. So here is example 3. Write 5 sine 3 theta plus 12 cosine 3 theta in the form square root of a square plus b square times sine b theta plus c, where c equals to arctangent b over a. So let's we have this is given 5 sine 3 theta plus 12 cosine 3 theta. So we let A is 5, B is 12, and uppercase B is 3. So we can find the angle C, arctangent B over A, which is equal to arctangent B is 12 and A is 5. And put on the calculator gives you 1.1760. Now we substitute A5, B12, B3, and C 1.1760 in this form. Square root of A squared plus B squared sine B theta plus C to get square root of 5 squared plus 12 squared times sine 3 theta plus 1.1760. So then B we change to 3. Now we simplify this one. 5 squared is 25, 12 squared is 144, and this will be 169, and this becomes 13. So we have 13 times sine 3 theta plus 1.1760. Example 4. We're going to write 5 sine 3 theta plus 12 cosine theta in the form square root of A squared plus B squared cosine B theta minus C. If C is now arctangent A over B. So let's start with 5 sine 3 theta plus 12 cosine 3 theta. So here A is 5, B is 12, and uppercase B is 3. And C is now arctangent A over B, which is arctangent 5 over 12. Put in the calculator gives you angle 0.3948 in radian mode. Now we substitute A is equal to 5, B is equal to 12, uppercase B is 3, and C is equal to 0.3948 in this form. Square root of A squared plus B squared cosine of B theta minus C to get square root of 5 squared plus 12 squared times cosine of B is 3 theta minus C angle 0.3948. And when you simplify, 5 squared is 25, 12 squared is 144, total 169, which is 13. So we get 13 times cosine 3 theta minus 0.3948.